Well, let's talk now to Lawrence Krauss, who's a professor at the School of Earth and Space Exploration. He joins me live now from Portland in Oregon. Great to have you with us on the programme today. So what are the main aims of this mission? What are scientists really hoping to find?
Well, clearly you've already heard about it. This mission is really designed with the thought of life, not so much looking at various other characteristics of Mars, but it's landing in a spot in Mars that was once hot and wet and had lakes and riverbeds, so signs of the kind of things you need for life. On Earth, you needed water, organic materials, and sunlight, and all of those things exist in the solar system. So this on Mars is perhaps one of the best places to look for life, and it's the first rover that's really been equipped to be able to do that in a serious way. Now, it's a long shot, of course, but it's kind of remarkable. Actually, the hardest part, I think, will be landing, and after that, hopefully all the instruments will work. And so drilling down, looking for any signs of metabolism of life, I think, are the key points. And then this experiment about looking for if you can create oxygen from carbon dioxide may not be useful for past life, but it will be useful to think about future life on Mars, namely human life.
So you say future life. Does this really then represent a potential forerunner of humans travelling to Mars and then more than that?
Well, yeah, maybe, yes, in principle. It's in principle. Right now, we can send rovers to Mars. We're not, no matter what Elon Musk may say, I don't think we're going to be sending humans to Mars in the near term. But it's a first step. These things are baby steps, and they happen slowly. And certainly, if we do send astronauts to Mars eventually, being able to generate their own oxygen is obviously one thing that's very important for keeping them alive. There are many other challenges to keep them alive. Also, there's the possibility of generating rocket fuel. So people have talked about one-way missions to Mars, where you actually create the fuel on the planet to come back. All of that is the future. It's not quite science fiction. But first steps first, and the first step is to see if you can effectively at least create oxygen. And so these are baby steps. Don't expect to get on a spaceship anytime soon and take a vacation in Mars.
And before all of this, of course, the craft actually has to land on Mars. This journey's taken 7 months, but how risky are these final few hours?
Well, as you know, they're risky because you can't communicate with the lander. You know, it takes something like 8 minutes or so, or 10 minutes, I forget exactly the number, for light to travel from Mars to here. And so therefore, all of the landing has to be done autonomously. And we won't know till literally 10 minutes afterwards whether it's crashed or landed. We'll see the videos that'll come, but those videos will be time delayed. So all of this has to be done remotely. And it has to land at a very specific spot. So it's the most challenging landing so far. But NASA's already done it. NASA's already landed a rover with a similar kind of landing mechanism without the cameras, and it worked once before. So we'll see. But you know, it's maybe better than 50-50.
Well, all our fingers are crossed. Lawrence Krauss from the School of Earth and Space Exploration, thanks very much for joining us.